Here are some reminders to help you get the most out of your DIVES CD lessons. First, work the problems with me. Work every single problem that I work and take notes on everything that I write on the board. One thing I encourage you to do is on the first practice problem, work that one with me, but then for the second and subsequent ones, pause the CD, try to work the problem on your own, then fast forward to the answer. If you got it right, great, you can move on to the next one. If you got it wrong, rewind the CD, look at how to solve the problem, and figure out how to do it correctly. Next, anytime you need to, pause and rewind the CD until you understand that particular concept. The ability to pause and rewind so easily is what makes DIVES CD lessons so much better than a live classroom lecture, so make sure and take advantage of that technology. Next, remember the purpose of math is to teach you to think and to solve problems, to effectively and efficiently think and solve problems. In the lower math levels, there's lots of mental math. In the upper levels especially, this is the most important purpose of math, is to teach you to think and to solve problems. Next, do all of the problems in the problem sets. It depends on the course that you're doing, but typically you'll do 3 to 5 problem sets a week, so that means 3 to 5 CD lessons plus a test. Next, work the homework problems and your test problems too. Work those vertically. Split your paper in two and work them vertically. And of course, make sure you show your work on your problems too. As you work them vertically, write each step down and write each subsequent step underneath the previous one. And this will help you sometimes to recognize patterns a little bit easier and help you solve the problem better. Also, use a calculator sparingly, only for geometry problems and some word problems. Don't use it for Math 7-6 or below that for any of that. Algebra half and up, use it sparingly. And lastly, have a good attitude. Every day you do school, you have a choice to make. It is your personal choice to have a good attitude, work hard, do your best, or to be lazy, complain, whine, and have a bad attitude. So choose right now to have a good attitude. Dive in, take advantage of this CD lesson, and do your best to learn the math that you're going to learn today. Lesson 49 is about the multiplication of polynomials. Now this is a really important lesson in algebra. If you understand how to do this, then it's going to make a lot of other concepts that you'll be learning in algebra that much easier to do and to understand. So make sure and get this down really good. And usually what you'll be doing in this is you'll be multiplying binomials. Remember, those are polynomials that have two terms in them. So let's just use an example. A plus B times C plus D. Now, actually, let me kind of back up there a second, and let's just do this. A times B plus C. Now, you've been doing problems like that. You've been expanding those, and you know how to use the distributive property. You would just say A times B, and then you would add A times C. So you'd say AB plus AC. That's the expansion of that relationship there. Now, the same idea applies when you're multiplying polynomials like these, and you would just take the A in A plus B, and you'd multiply that by C and D. Then you take the B in the A plus B and multiply it by C and D. So you just kind of do a double expansion. You can kind of think of it like that. And that's all you're doing. So just look at the A by itself, and you'd say A times C, and then plus A times D. Then you go to the B, and you say B times C, and then plus B times D. And so that would be the expanded form of that polynomial. Now, if you're not sure why that works the way it does, let's just use numbers instead of letters. Let's do 1 plus 2 times 3 plus 4. First, we'll do this by adding first, then multiplying. And so that would be 3 times 7 is 21. And then we'll multiply first, then add them up together, or in other words, use the distributive property. So just like we did in that first one, we would take the 1 and multiply it by the 3 and then by the 4 in the second term there. 1 times 3 is 3, and then plus 1 times 4 is 4. And then we'll do 2 times 3, that's 6, plus 2 times 4 is 8. Okay, so then we can add all of that up together. 3 plus 4 is 7, and then 6 plus 8 is 14. So that totals up to 21, just like we got before. So that does work. You can do like a double expansion on these problems that have binomials multiplied by each other. Take the first term in that binomial, multiply it by the terms in the second binomial. Then take the second term, multiply it by the terms in the other binomial. And that's how you do these. Let's go ahead and do a practice problem. Look at practice problem A. And let's expand that out. Now in the problem set they won't call it expanding anymore. They'll just say multiply. So when you see that, that means that you take that first term in the 3x plus 2 and you multiply it by the two terms in the second binomial. So you say 3x times 4x plus 3x times negative 1. And then you do the 2. You say plus 2 times 4x and then plus 2 times negative 1. Okay, now you just need to simplify this next, and so you have 3x times 4x, that would be 12x squared, and then 3x times negative 1 would just be a negative 3x, and then 2 times 4x is a positive 8x, and then 2 times negative 1 is just a negative 2. And so now we add the like terms there, the negative 3x and 8x, and we'll have 12x squared minus, plus 5x minus 2. And that's the way you should write the answer. We have it in descending order of the degree of the variables. The second degree variables first, then the first degree one, and then the 2. Now look at B. I want you to multiply that one. And one thing, you should kind of make the connection here. All these problems you're multiplying binomials together. So when you see 2x minus 3 squared, don't panic. Just realize, oh, well, that squared term, that means everything in that quantity needs to be multiplied out twice. So really, that's saying 2x minus 3 times 2x minus 3. That's just a simpler way of writing 2x minus 3 times 2x minus 3. It's the same thing as 2x minus 3 squared. If we had 2x minus 3 cubed, that would be 2x minus 3 multiplied out 3 times. So let's go ahead and multiply this. The 2x on the left, we'll multiply it by the 2x on the right. And so that, let's just do that in our head. That'll be 4x squared. And then multiply that 2x by the negative 3. That'll be negative 6x. Now take the negative 3 on the left, multiply it by the 2x on the right. That'll be a negative 6x. Then take the negative 3, multiply it by the negative 3 on the right, and that'll be a positive 9. So we skipped a step there compared to A, but hopefully you realize and understand what we're doing here. And let's simplify this. That'll simplify down to 4x squared. And then we have a minus 6x and a minus 6x. That's a minus 12x. Plus 9. And so that's our solution there. Let's do one more. Now look at this problem. We have a binomial and a trinomial, but we still do this the same process. We'll start with that 2x squared and multiply it by every term in the second polynomial there, or the trinomial. Then we'll take the negative 5, multiply it by every term in that trinomial. Same steps. So let's go ahead and get started. We do 2x squared times x squared. That's going to be 2x to the 4th. And then we'll do 2x squared times negative 3x. So that'll be negative 6x to the 3rd. Then do 2x squared times 1. And that'll be a positive 2x squared. Next, we'll take the negative 5 and multiply it by every term on the right. Negative 5 times x squared is a negative 5x squared. Negative 5 times negative 3x is a positive 15x. And then negative 5 times a positive 1 is a negative 5. Okay, now Let's see if we can simplify anything here by adding like terms, and we have those x squared terms to add together. And so we'll end up with 2x to the fourth minus 6x cubed minus 3x squared plus 15x minus 5. And that's our answer to that multiplication. Make sure you understand that process of multiplying polynomials. It's just like doing an expansion, except you do it on each term within that polynomial expression. Okay, well that's all for lesson 49.